Today I'm going to attempt to re-wax a flyback transformer, and I'm going to try and force the wax into it using atmospheric pressure. I'm not talking about just melting a candle over the outside with a heat gun. What I've come up with is this is a vintage Presto pressure cooker that I got off of eBay, aluminum, and originally it had this little relief valve vacuum brake nipple in here, and what I did is I siliconed a piece of plastic over the top of it. And here's my vacuum pump and my stove. And here's the failed flyback I'm going to try and re-wax. And what this has done is, you can see the tire has arced out. The tire's become conductive, and it's also lost most of its wax. I did do a DC resistance check on this, and it checked okay. Next thing I'm going to do before I actually re-wax it, I'm going to do a ring test on it. And as you can see, the flyback checks good, 12 rings, which is the same as this new old stock one right here. I'm using this one for comparison. So it appears that this flyback is just arcing out, and that's what we're going to try and fix with the re-waxing. So the next step is to cut this green tire off, to remove all this silicone and green tire. So I got the tire off, and you can see where it's been arcing here. Surprisingly, this thing is covered with a very thin layer of silicone, and it looks like it's just been arcing from the high voltage out right to the core. I'm going to try and pull all this silicone off. Here's something kind of interesting. You can see how small the actual winding is. It's only about, it's less than a 1/4 inch in the middle of this 1/2 inch donut. And it's just stacked. Since this is surely for experimental sake, I'm just going to do this real quick. I cut the wires. You can see whoever replaces cut the tabs off anyway. I cut the wires off. You probably can't see that hair wire, but that thing pulled off, and the wire, it turned out the wire was broken right there where it connected anyway. I scraped as much of the arcing crap off as I could, the carbon, and I'm going to pull this apart and take the donut out. So I just cut the wires off the board there as close to the terminals as I could so I could resolder them. Here's our donut. You got to be mindful of all these little spacers and shims and wedges, where they all go. You can put it back together. Just simply leave that intact and then bend that open. And these circular little donut things go on the tip of the core, so the core doesn't touch. So we're pretty much ready to re-wax this thing. I wanted to show, this is all the silicone I pulled off the donut. And this is the actual donut itself. You can see where it had been arcing. And it looks like they tried to do what I'm going to do, which I know that's blurry, but they tried to pressurize this thing and force silicone down into the air air gaps, but they didn't do a very good job of it. Okay, the next few segments are going to be some testing to see if this equipment will handle this pressure, or rather vacuum. So what I have is I have my pressure cooker connected to, this is a refrigeration oil injector, and usually what you do with this is you fill this with 2 ounces of oil and inject it. Use the refrigerant pressure to inject it into the refrigeration system. What I've done is I've stuffed this with paper towel, solid, to keep hopefully any wax fumes out of my vacuum pump. And then we're coming up into the refrigeration gauges, and then we're coming over to this 2-stage deep vacuum pump, and this will pull I would say 98% of the air out. So what we're going to do is just test this, see what happens. Very possible the pot could implode. Leaking, it's not. It's only getting down to 20 inches of vacuum. Let me see if I can find the leak. Okay, I can get okay vacuum in it. I can't get the full 30 inches that I want. So the next step here is to melt this wax in here and then pull a vacuum on it and see if it explodes or not. I know when you lower the pressure, you lower the boiling point, and I don't want to have it completely full of wax before I test it, so I'm going to just try a little bit. Okay, so let's go. Let's see what happens. Something popped there. Oh, look at that, it broke my seal. think maybe there's a little moisture in this wax. Okay, let's see what our 397 degrees. So let's see how much moisture is in this guy. Deep fat frying a flyback. Look at the bubbles coming up out of it. Come on, baby. Look at all that moisture and air coming up out of that thing. What I'm going to do is I'm going to turn the heat off. Wonder if that's all moisture boiling out of that thing. Boy, that's a trip. Oh, do this outside on a piece of plywood. So I know there are a lot of people that really like hot wax, but this makes a mess. Deep fat frying a flyback. I'm going to let this do this until it settles down. What in the world could that be besides moisture? Boiling off. Okay, so 20 minutes later, it's kind of starting to mellow out. I'm really assuming this is all just moisture boiling out of this thing because our wax temp is 406 degrees. No wonder why these things fail all the time if they have this much moisture in them. I guess it's been sitting for 30 years unused, and it is paper, so it probably just absorbs a ton of moisture. So I'm going to wait until this completely stops, and then I'll pull a vacuum on it, and that'll pull any air that's hidden deep down inside out of it, and then when I release the vacuum, wax will replace the air. Okay, so after about 45 minutes to an hour, it's still bubbling a little bit, and as an experiment, I wanted to stick a pine cone in there and see what the moisture in the pine cone looked like. Oh, deep fat fried pine cone. So David, I got my friend David on the phone. Let's talk about a couple of these ideas on this video. As far as like a valuable TV, like a CT100 or something that had been sitting up for 40 years and drying the flyback out, but prior to turning it on.
That passes a direct current through the high voltage and trying to internally generate some heat.
Yeah, running maybe like 5 milliamps through the secondary winding to draw.
See how that could hurt as long as you monitor not only the current but just the overall heat. I mean, if it doesn't get too hot, then I don't see how it can possibly hurt. It might help drive out that moisture.
Right, or maybe even if it was something like a CT100, removing the flyback and putting it in a dehydrator for even up to a month. I mean, you're talking about a TV that is so impossible to get the flyback for.
Right. You could seal it up. You could put it some way to heat a slow heat, and maybe put desiccant packs in there to help absorb any moisture that does come out, and really dry that thing out. The moisture, I don't see how any moisture could ever be considered good, so it would make sense that you should be able to remove as much as possible. But then, is there some way to reseal it back up once you've gotten it out?
Well, once it would be in use, then it should theoretically stay dry from the heat, or dry enough.
In the temperature control environment, which I would assume you would, and then from the regular use, yeah, you're right.
Wow, even this pine cone is drying out faster than the flyback. I mean, the flyback is still bubbling along an hour later, and the pine cone is pretty much.
It's safe to assume that the tire has been, from what you're describing, it sounds like it's made up primarily, or at least a fairly large portion of it is just paper. I guess it makes sense that it could absorb a lot of moisture over a period of time.
Oh, the donut is probably 80% paper.
Yeah.
Here's just a little stick that's been laying outside, so this should be nice and wet. Still at 394 degrees. I don't know how long it's going to take all the moisture to come out of this thing, but I'm going to just let it cook. Here's a chunk of wax off the actual flyback. Let's see what this does. Nothing there, so there's no moisture in that. Okay, all bubbling has stopped. Vacuum time. Do this kind of quick. It's got a good seal right now. I'm almost down to 30 inches of vacuum. That's it. I'm in a deep vacuum. So right now, any air that is in that flyback has been sucked out, and when the pressure is released, it will force wax back in. Wax temperature is 300 degrees. So what I'm going to do is I'm going to just turn it off. and let the pressure come up very slowly. In fact, I'm just gonna, it's got a very minute leak somewhere and it's creeping up, so I'm just gonna let it lose vacuum on its own account. So it looks like the wax starting to harden now around 180 degrees, so I think it's time to take it out. What I'll do is I'll take it out and I'll kind of rotate it around until it gets solid on the outside. This thing is just one solid block of wax now. I stuck it back on the core just to line it up because it was loose and you could rotate everything around. So what I'm going to do is let it harden for a couple days, and then I'm going to cover it in silicone. Just encase it in silicone like the third arson transformers are. And probably next week or the week after get it stuck in a Packard Bell set, which is what it's from, and check it out and see how it works. I do expect it to work though, at least for a minute. Here's kind of the semi-finished product. A nice white silicone one donut. Should keep some of the moisture out, I hope. And this will be the end of this video. The next, I'll be sure to post an update if this works or not. I'm going to let this dry for a few days and then put it back together. Probably be a week or so before it's back in a set.